Hello, sixth grade. Investigation 4.3 summary for variables and patterns. So, how do you check once you've combined like terms or to prove that your expressions are equivalent? Well, one way is to use substitution. And we use substitution, again, that says to prove that expressions are equivalent. You must substitute more than one number to make sure they're equivalent. In other words, we're going to show you, don't just say, like, oh, okay, we're going to choose 3 for X. You have to do it twice just in case, because sometimes they show that they're equivalent and they're not. So to review our substitution, again, we want to rewrite the expression or the formula. Then you substitute the variable with the given value. Again, if you have 4y, you want to make sure that you place the multiplication sign in between, and then you solve according to order of operations. So we have 3 different equations here, and we want to see if these equations are equivalent to each other. So it says choose a value for each variable. So let's say, let's use L is 2 and W is 3. I like to use nice easy numbers. Why make our life harder? So now here is my equation, L plus P equals L plus W plus L plus W. So now I'm going to substitute my values. 2 plus 3 plus 2 plus 3. According to order of operations, I can just go with their addition, so I can go in any order. I have 5 plus 5, which is 10. Okay, now I'm going to substitute it into this equation, because again, my goal is to see, are these equations equivalent to each other? So 2L now becomes 2 times 2. Remember, I put my multiplication. You can put the X in. I like when I'm dealing with variables to use the dot, plus 2 times 3. So according to my order of operations, I'm going to do 2 times 2, which is 4, plus 2 times 3, which is 6. I add them together and I get 10. Notice I always keep putting the p's here because this side of the equation is already simplified. Okay, so right now, these two equations, according to this, are equal. Let's see if they're equal to this one. P equals 2 times L plus W. So again, I'm going to put L is 2 and W is 3. So I'm going to simplify in here, and I will get 2 times 5, and 2 times 5 equals 10. So according to these two numbers, these 3 equations are equal to each other. But we always just want to double check. So let's use L now as 4 and maybe W as 5. We're going to go through the same steps again. Rewrite my equation. Substitute my values. Okay, now I have 9 plus 9, which is 18. Now remember, these have to equal each other, not these, because our numbers that we're substituting are different. So 2 times 4 plus 2 times 5 equals 8 plus 10, which equals 18. Okay, so again, we have it checked off that these two happen to be equal to each other. And then finally, I forgot to originally write on the other one my formula. 2, 4 plus 5, 2 times 9, P equals 18. So what this shows is that these 3 equations are equivalent to each other. They're in just different formats. If you could see, L and L become 2L, W and W become 2W. Okay, now here they use the distributive property, which we're going to look at on the next page, and said, oh, 2 times L gives me 2L. 2 times W gives me 2W. So that's how we can show that they are equivalent. Now let's take a look at the next page. And a little review of the distributive property, but this time we're going to be using variables. Now, if we remember back from the beginning of the year, the distributive property said that I can take this factor and I have B plus C. Well, that's the same thing as saying A times B and A times C. When we did it at the beginning of the year, we used the visual that here's A, B, and C. And we said A times B which is that, A times C, which is that, is the same thing as saying here is my length, and my width is B plus C, which comes here. Now, another way of thinking about this for some people, because it's a little bit harder, is if I have 3 times x plus 5, which means I have 3 groups of x plus 5. So here I go, x plus 5, x plus 5, x plus 5. Well, if I combine my like terms, x, and x, I have 3x. If I combine 5, 5, and 5, I have 15. So therefore, I have 3x plus 15. So that's another way of looking at it. Okay, I can also see this as multiply the outside number by the first term. So I'm going to take 3 and times it by x. So here I'm taking this and timesing it by x. So let me write it over here so we can see it right above. So I take 3, multiply it by x, and I get 3x. Then I take 3 and multiply by 5, and I get 15. Okay, so now I have, insert the operation sign that was in between, I have my 3x plus 15. So these expressions are equivalent. 3 times the quantity of x plus 5 equals 3x plus 15. So let's take a look in practice down here. Here is my factor form, meaning I have one factor and then my other factor is in the parentheses. So I can either think of this as 5x plus 4s. So this helps you write x plus 4 5 times. So I have 1, 2, 3, 4, 5 x's. And 4, 4, 4, 4, 4, 4, 5 times is 20. Or we can think of it as 5 times x is 5x. 5 times 4 is 20. Okay, let's use that term instead of doing this. Okay, 7 times 3y. Well, I can only do 7 times 3, so that's 21y. And 7 times 6, which is 42, plus 42. Again, it's saying I have 3y 7 times. Right? If I do it 3y, 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 and all the way down, we'd have 7 times. So again, this is how we now are taking the next step in using the distributive property from the beginning of the year and playing it into equivalent expressions.